Hello, welcome back to Cinderella Math. And today I want to do kind of the topic that inspired my channel name here of Cinderella Math. It is a crucial topic all the way from pre-algebra, really until you're done with math, all the way up through your high school math career and even beyond if you continue on. So it is the process of converting a line or a linear equation or linear function into slope-intercept form. So that's what I would like to practice here today. So I'm going to just teach how I use my quote Cinderella method to get this done. So I'm just going to come up on top of here and let's first talk about linear equations. You can see that root word is line. So yes, when they are graphed, they make lines. I'm not going to focus a lot on the graphing here in this video. That can be done another time. But for now, I just want to point out the root word here and how these do turn into lines. Oftentimes, they are given to us in something called standard form, which looks like this. AX plus BY equals C, where A, B, and C are coefficients. And there's nothing inherently wrong with standard form. It is fine, and there are times in math where we actually prefer standard form. But for the most part, we would like the lines to be given to us, or they're easier to work with, typically in slope-intercept form. So we're going to take this given standard form and we are going to transform it with our magic wands into y equals mx plus b form, which is slope-intercept form. Now, over the years, I've been teaching math for over 10 years now. I have come to call this as our Cinderella form. So any video you see from me and I say Cinderella or Cinderella form of a line, this is what I am referring to, the slope-intercept form. And part of the reason I call it Cinderella is because it's, quote, pretty. It is easier to work with usually than the standard form, and it's especially the preferred form if you are going to be graphing that line. Okay, so that's kind of the origin of the Cinderella and what we're going to be learning here today. We're going to take a standard form and convert it into Cinderella form. And I have invented a verb for this. It's called Cinderella, is also a verb, or I might call it the Cinderella process. Okay, so I would like to do some examples now. All right, here is example 1. We're going to have 5x plus y equals 8. So that is in standard form, and we're going to turn it through the Cinderella process into slope-intercept. So how I like to do this is I find y, and I'll actually call y Cinderella. She's our princess, if you will. And the princess needs time to get ready for the ball. She needs to be alone to have time to do this. So we need to isolate the y, get her by herself. All right, so I see on that same side with y, I see the 5x. I need to move that. That is a positive 5x, so we're going to subtract it, and then we'll subtract it over here. Now, usually, we're going to put the x first. So the way I actually have that written on the right-hand side, I don't prefer that. While it's not wrong, I would say it's not preferred. So actually, let's put the x in the front. And my cute little way to remember this is x gets in the carriage first, continuing my Cinderella metaphor with the pumpkin turning into the carriage. So we're going to say minus 5x right there. So we have y equals negative 5x, and that 8 is just a positive 8. And there she is. We have taken the standard form into slope-intercept, aka Cinderella form. And you're done. We could, of course, go ahead and graph this now. I'm not going to do that right now. We could, but this is good enough for today. Right. Example 2. I'll split my screen and also do example 3. Okay, there's example 2. So again, that is standard form. There's nothing inherently wrong with that. It's just usually preferred that we go to slope-intercept. We find the y, that's your princess, and we need to isolate it. So this one's a little harder than the previous example. First, you want to go ahead and get the x over. So we do have a positive 4x. Let's go ahead and minus that. And we'll bring it to the other side. Again, my little saying is x goes in the carriage first. So I'm going to say that's negative 4x with a normal 10. And now the princess is looking better, but she's still not by herself. And again, she's getting ready for the ball. She needs some privacy to put on her sparkly dress. So we still need to remove that negative 2. And this is an invisible multiply, yes? Whenever two things are stuck together, they are being multiplied. So let's do the inverse operation of multiply, which is divide. Going to divide by 2 all the way across. Excuse me, negative 2 all the way across, which will leave the y by itself, which is what we want. Negative 4 divide negative 2 is 2 with an x. 10 divide negative 2 is negative 5. And there she is. We have isolated the y and put that into slope-intercept form. Right. Example 3. Right. You'll notice that this time that's actually not in standard form, and that's okay because the x and y, technically x should come first, then y, but that's fine. We can still take that equation, it's still a linear equation, and put it into slope-intercept or Cinderella form. Find the y, there's our princess, she wants to be alone. First, let's get the x. That's a positive x, so let's minus it over, giving us 3y is negative x with a regular 9. Again, x goes in the carriage first. There is an invisible 1 right here, that coefficient. If you want to slide it in, you can. And now the y is still not by itself. We need to divide off the 3 to get that. And again, there's an invisible multiply. So let's divide to get the y by itself. Divide all the way across. So y is negative 1/3 x. 9 divided 3 is 3. If you did not put that invisible 1, also acceptable would just be negative x over 3 plus 3. If we're going to graph it, I would probably put the 1 because this is easier to see as a slope. Right? So I personally prefer the 1, but they both are correct. And I'm going to do 2 more examples, and then I think I'll leave you there. Example 4. All right, there we are. And we need y by itself. Let's move the x stuff over. Now this time the x is negative, so we'll add it. Again, just always doing the inverse. So that's going to be positive 2x minus 15. So technically this is a plus right there, but when it's in the front, we don't write a positive, yes? And then we'll divide the 5 to get the y by itself all the way through. So we have 2/5 x minus 3. And one more. Okay. We want the y by itself. Let's move the x. That's positive 8x, so we will subtract. That goes in the front. That 12 is regular or positive 12. And then let's divide all the way through by -4, giving us 2x minus 3. Watch your signs there, and you'll get it every time. So that is my Cinderella method. It's nothing different than any other teacher does to turn um, standard form into slope-intercept, but hopefully with the cutesy way of thinking it as a princess, getting her by herself so she can get ready for the ball, putting the X in the carriage first, just gives you a few more tools and memory devices to always be able to turn a line into slope-intercept form. I hope that was helpful, and I hope you're having a great day. Bye-bye.